In connection with array pointer, this dynamic memory application, dynamic memory allocation, that part will also come. Okay, some examples on arrays that will also discuss there. 2D arrays, those things are there. So today's topic is this function pointer, basically. Okay. So here you see in function pointer, there are some variation of this function pointer by lexical meaning. Function pointer means a pointer to a function which is defined something like this, okay? So where it points, but in addition to this, there is some more part to it. Let me tell this. That is not basically a function pointer, but there are functions which contain pointers as arguments, some other applications. There are functions which return pointer as the output. So those two are separate issues. But what we mean by function pointer is basically a pointer to a function. So what we already learned is that in case of pointer, the pointer always addresses to the first location of any data type. That means if it is an array, that one is the first memory location of that array. Or if it is a double data type, which requires more than one byte of data, then it points to the first location of the memory address, where from that double data storage starts. And as you know, for any pointer variable, we have to declare its data type. So compiler knows how many memory addresses it need to read from the memory for that particular pointer data type. But what about function pointer? The function pointer share many similarities with ordinary data pointers, but they differ in several ways. Here you see, the idea is something like this. Here it is. Now, say in our program or in any compiler, when we run a program, that memory stack, which depends on the hardware of the machine, rather the number of bits of the operating system, we have a memory stack. And usually memory stack, this is a representation of that memory stack. So previously you go to computer architecture, there you have shown those RAM and other things. Okay, physically those are the things where computer holds the memory. Okay, in representation, what we represent is that, see, this part from bottom part, this is low memory, and to the higher end there are high memory. That means for a 32-bit, it will be something 4 GB of RAM. Okay. Now, this memory part is divided in several groups. That division by default is done by the compiler. So when you have installed the compiler, there was the default option. Okay. So we are not that expert to change the default setting, but if you are expert enough, then you have the option of changing those setting of the compiler by which you can change the amount of memory in these different blocks. Okay. Now, our part of interest is mainly the stack and heap. And what are these things? Some part, this text part, this is a machine instruction which comes from the operating system directly. Okay. So for your Windows version, Linux, whatever, it takes up some part. And then the next part, basically global data. And you have seen previously, while declaring a variable, we had an optional scope of declaring storage class. We didn't mention about that. But if we make it a static type data, that we declare storage class of a variable is static, it goes here along with the global data. So this part is fixed for the particular session of that compilation. Just a minute. Okay. So now what happens when our code, say for any function, we have a code which starts with main. This main function is necessary. Without a main, a C program will not run. So in the stack itself, first part is the main, which comes in the stack. Okay. And then a particular function, it can contain many sub-functions. Besides the main, it can have many functions, 1, 2, 3, 4, etc. And these functions, they are stored or stacked up on this main. So first, this main is loaded in the memory block. And then when this main encounters a particular call to a function, you know the execution from the main passes to that particular function. That function is loaded here. So when that function is executed, it again comes back here. Then it encounters another function, it is loaded there. That way our program executes in connection with the memory block, the memory stack of the computer. The next part is the heap. So which one is heap? Now during execution, the computer requires some memory space for computation purpose. Say a particular application is a multiplication of two matrices. So that part requires some memory for the calculation. Or say for any program, whether it is within the main or within the function, it requires some memory for the calculation part. Okay. So that part of memory is allocated by the computer itself. Okay. So that part is allocated from this heap. Now you see here what happens by default. The computer compiler allocates a particular amount of memory for this session. Okay. And there is a high end of the memory. It won't go beyond that. So heap goes this way. Actually, this is only a physical representation, okay? Or you can say a graphical representation. What happens inside the computer in some electronic arrangement within the memory block. That is of no interest to us. We are trying to understand the situation, what is happening there. And then you see sometimes when you know about recursion, right? When we had example of factorial, there was two ways of computing factorial. One was a recursion. Okay. So what is a recursion? Recursion is basically factorial n is n into factorial n minus 1. Okay. So when that program starts, okay, so it requires some heap. So it does a calculation. So current value of n is say 12. So 12 into, then it gets factorial 11. So on top of this factorial function, this factorial function was factorial 12. This is called another function which is factorial 11. It will go there. Then in the heap, there would be another calculation. Now 11 into factorial 10. So heap will grow in this direction, stack will grow in this direction. Okay. And you know that there is a limit of value, integer value, up to which you can calculate the factorial. Even in your 32-bit system, there is a limit beyond which you will get a message of stack overflow. So this is another part of the story, but this is how memory is managed during a program execution. Okay. So our question is, what this function pointer indicates? Usually, ordinary pointer, it points to a location, okay, or the starting location of the data, a particular data type. But for a function pointer, it points to the initial memory address of that particular function. Okay. So if it is a pointer to function 1, then the pointer to the function will point to the first executable statement of that function. So this is what is designated by that. Okay. So this is meant by a function pointer declaration. Okay. Okay, then we can dereference an ordinary data type, but for function that is not possible. This is quite understandable. Okay, let us see another part here. Let us not make use of any function pointer right now. This is what is meant by a proper function pointer. Okay, so that we will be using a bit later. Right now, let us use some function which first contains some pointer arguments. And then we'll see another example where the data type or output data type of the function is a pointer data type. Okay. So that we'll see first. Okay, so here, one idea, this also we have discussed previously. So when a function is called by some values, for example, here the argument of this interchange function is two integer values. So when it will be called by the main function, in that particular case, it would be a function call where arguments are passed by value. Okay? So when we use pointer as function argument, okay, like in this particular example, you see, here this is we made a distinction previously. In the declaration, these are parameters. In the call, those are the arguments. So whatever, there are other terminologies also. Say these parameters are two integer pointer. And when this is called, here we are not passing the value, right? So what we are passing, basically, the reference or reference to the memory address. Okay. So that type of function argument. So when we pass pointers as function argument, this is called pass by reference. Ordinary use of function where we pass value explicitly is passing argument by value. So let us see example of this. So you see, in some previous lecture, we discussed this particular function. Right? So here, the function is add. So this is an example of passing value, passing argument by value. Okay? Within the main, this function add is called, 3 times this is called. And within this function, these two integer values, they are added. We understand this thing, this we have discussed. So this is an example of function arguments or passing function arguments by value. Okay. So this particular program, we can change like this. Actually, instead of this thing, okay, instead of this thing, we can now reduce this one here. What is done is that uh, this is an example of passing multiple values. So, you know, usually in a function, the return value is a single value. But this is a mixed example where some function, this function is a particular case where some of the arguments are passed as value, some of them are passed as function, as pointers. Okay. So actually the purpose was to pass both this add and subtract these two values from this function. Okay. Now let us see this function, then we'll see what happens now. So here you see in the main, this is our main, right? This is our main. So there are 4 integers, 2 of them are initialized, and then we have 2 more, which is P and Q, right? And this particular function calculate is called from there. Right? Now, You see, this is an example where A and B are two arguments which are being passed, okay, in this function. Those are getting values x and y there, right? And then these two integer pointers, they are being used to pass the value to the calling function. Okay. So instead of returning any value, this is a void type function, right? This particular function is returning two values. How it is returning the values? By using this integer pointer. So you see, when we have a list of argument, okay, if we change the value within the called function, that will get reflected in the calling function as well. So this is what is being done. And you see here, what is this particular star add pointer? This is pointer to an integer whose value is, this is, okay, is x plus y. And then this is another integer whose value is x minus 1. Okay. So these two values, asterisk add, asterisk sum, and this asterisk subtract, they will be, okay, mapped to these two locations. Is it okay? This is a memory address. So during the call, what we have called, these two are integers, A and B are integers. This is memory address of integer P, this is memory address of integer Q, right? And that memory address we are getting from this particular function, calculate. Is it clear from here what is happening? So what is being returned, actually here, returned value is coming from the list of arguments, okay? There is no explicit return. So it is a case of implicit return. Okay, this is the thing. And let us run this. Oh, here it is written that sum is 31 and subtraction is 9. Okay. So this is what should happen. 20 plus 11, 20 minus 11. So that part is okay. And so this is a mixed type of example. This is not an example where we used pure, it is not a case of pure passing argument by reference. Some part is by value, some part is by reference. Whatever, you get the idea. There is another part of it, I'll be telling that. But before that, let us see another example where the return value is of type pointer. That same function, calculate, here it is defined like that. What it is? The function argument is two integer variable, so it is x and y. And then within the function, we have another integer add, which is x plus y only. And what it returns is the memory address of this add. So its return type is an integer pointer. right? Now, this is the main, where we have integers a and b, which we will be reading from our keyboard by using the scanf. And then we'll call this function. Okay. This function call requires two arguments. These are integer arguments here. Those are the values we read from the input. Now, what is the return value of this particular function calculate? It is stored in C. What is C? The C is a function pointer, okay, of type integer. So is it matching with this function return type? Clearly, this return type is an integer pointer. And what is that integer pointer? It is the memory address of this add. Right? So now you see here, if we print C, what we get? Here, let us add that also. And let us make it. Okay, let us %d and %x. Okay, you understand now. So what is this C? What would be this C? This is a pointer. Okay? So this will print the memory location, a particular memory address. It will print in decimal digits, and here this will print the same thing with hex code. Okay. And the star or asterisk C is the value, okay, which is stored in memory location of C. Okay. Let us run this. So here I have entered two integers, say 20 and 11. Okay. Okay, so here again, I'm not enlarging this. So what is here is these are the memory address, and finally we should get the result also. Okay, let us do one thing. Okay, let us make this comment first and see the return value here. So once again, 20 and 11. So you see this result, it is showing the summation is 31. Okay. And okay, previously let us put a new line character here. And let us run once again. Again, 20 and 11. Oh, just a minute. Oh, sorry. Okay. So again, some error is happening. I need to check this once again. So, whatever, this is giving some problem with this printing of memory address. But you see, this is some example where the argument type is a pointer, or the output type is a pointer. Okay. Now, let us see what happens. So let us make it a percent x and a and let us see. Okay, whatever. So with this printf, this is this particular statement is not working. Whatever. Now the point is, what we are printing here is the memory location of these two variable a and b. Okay, this a and b. Now, what would be the memory location of this x and y? Any guess? So we print this one here. What will happen now? Did you get me? We have two integers, okay, here. Integer a, integer b. What we are printing here is the memory address of this a and b. So this a and b, they are being called by this function. This is the call. Okay. So this a and b is now mapped in x and y. Right? So what would be the memory address of this x and y? Let us see. This is what we are printing once again, the memory location of x and y. Okay, let us run. Okay. What is the error? Expected declaration specifier.
Sir,
What is the error?
sir, shouldn't those printf statements be inside the bracket?
No, why? And x is the memory address of this integer x. Let me try one thing. Let us make it x xx. So let us make it yy. Okay. Sorry. And here, let me declare int star xx. Okay. Int star yy. Okay. And then let me assign this xx equal to and x, yy equal to and y. Let us see.
Sir, the function opening bracket is not given.
Wow. Yes. Yeah. So this is the error. We're right. Okay. Thank you. You are always smarter. Anyway, I have to run it once again. So the point was what happens to memory location. Okay, let me run the program once again. 4 and 5. I have some result and let me see. You, you see, these two memory address. These two are coming from first, where is the call? These two. That means they correspond to this value x and y. Okay. This A and B, they are the memory address of this A and B, right? So quite clearly, this X, Y, their memory address is different. Okay, this F0, F8. Here again, these two memory address for A and B, they are different. Okay, so what is happening in this particular case is, you see, right. So if we see here, now in this stack, there was a main, and within the main, we had A and B. So that A and B is copied in function one, whatever is the name, calculate there. So those are again copied to some new memory address within this function, right? But when we will do it, say instead of this thing, when we'll do it for this particular one, then we'll see that the memory location of this P and Q, okay, this P and Q, they would be identical with this memory location of add and subtract. This is one difference. This will happen. So again, we need to make a program correspondingly to see, okay, that those memory address will remain the same. Okay. So what you need to do, I am giving this thing as a task for you. Okay, you repeat this program. You add this thing, and instead of passing by value, you pass argument here. You pass argument by reference. That means you pass pointer variable, and there you print the memory address here once again. Right? And then you will see that these memory address in the main and in the function, they will remain same. That means we are not creating a new set of memory location for those variables. Okay. Now, sometimes this is of much benefit when we deal with some array or other variables which require a lot of memory space. Okay. That is one observation we get from here, right? And then we have another observation, say from here itself, say, let us take this example. This is the previous example. This is passing by value, whatever. Now, no, here will it do? In the main, what it is? These are explicit values. Let us see here. Okay, now let me do one thing. Let me change this x as a. Let us make it b. So what is our add? A plus b. What is subtract a minus b? Okay, so will it conflict? In the main, we have some definition for a and b. Here, again, we are using that a and b. Will there be any problem? Let us check. It has given the result. Sum is 31, subtraction is 9. So no problem. Tell me why there is no conflict. This is an example of the scope of a variable. You see, when we were discussing about variables, there we mentioned about the scope of a variable. What is the scope of a variable? It is within the function or within the compound statement. Okay? So this A and B, their definition is local to this main. When we are going into another function within, say, this calculate function, this A and B is again defined locally within this calculate function. Is it clear? So that is why this A and B variables of the main, they are not conflicting with the variables A and B of this calculate function. Clear? This is clear? Okay, so up to this much, what we have seen is example of pointer variable, which is being passed as argument or as return type. Okay. But now let us go into the proper use of function pointer. This is the function pointer. Let us go an example for that. Okay. So how we understand that there is an example of function pointer. You have to see this particular one. Okay. In general, for any pointer, if the return type of a function is any pointer variable, that won't be within the parenthesis. Okay. So when this is a pointer type and within a parenthesis, this is sufficient signature that this is a function pointer. And then this has to be followed by at least some arguments, or if it is a case of no argument, then at least you have to keep this parenthesis, just open it and close it. Okay. So this is how we understand that we are defining a function pointer. Okay. Let us see example of that. Okay. Whatever. This leave it. This is what we discussed. Whatever. Here, this is optional address operator. This is structure. What is it? My add, my multiplication. Okay. Then Whatever. Okay, this is a some example, whatever. So that entire program need to be developed. So here you see two examples are there: addition, multiplication. Some more we can do, division, subtraction, and then what is written here? We we can use them in function call, and you have seen the switch command or switch example of control statement switch. Okay, there are different cases. So that way, by such definition of functions, by such definitions of functions, it is possible to switch some according to some choice, the required function will be executed. So the entire program need to be developed. There is another one. Let us see that. Okay. Arrays of function pointer, that is also possible. Let us see this example. Example prints table showing values of cos and sine. So here you see this is a particular example where we have used function pointer, but the functions are not defined explicitly. Rather, the functions are taken from the predefined math header library. Okay. So you see, in this particular program, we are using these two functions, cos and sine. Their definition is not explicit here. Like in this case, we had some explicit definition of some function, addition, multiplication, etc. And here, what is used is these two functions, cos and sine. Their definition is already available in math.h. So then you must know one thing, that is, what is the data type of the argument and what is the return type of this sine and cos function. Actually, that is listed. If you open any .h file, this is an ASCII file for any library header file, you can open it. Those are ASCII files, and what information it will give? It will give for all the functions which are listed in that header file, what is the return type, return data type, and what are the list of arguments for that function. Okay. So for cos and sine, okay, the return type is double. Understand, it's a floating point in double position. So both cos and sine, they require only one argument, cos theta, sine theta, and those values should be in radian. Okay. So this is the format. And what next? Here, this is the function we are defining. Sorry, this is not the function. Rather, this is something void tabulate. No, this is basically the function definition. Return type is void, tabulate is the function. Okay. So the argument is first one, this is a pointer variable. Is it clear? This is a pointer to a function, say function is f, whose return type is double, and whose argument, only one argument is required, which is also double. How we understand this is a function pointer? By this star f. Is it okay? This is what we have just mentioned here. This is how we understand that this is a function pointer. So this is the declaration of our function tabulate, which is defined here. And then this is our main function. So in the main function, we have three variables. Those are initial, final, and an increment. All of them are of type double. Okay. Now these values, initial value, final value, and the increment value, this is what we are getting from our input part. Okay. And what we are printing here, this is what we are printing. There is a call, okay? There is a call to this function tabulate. Now this particular function is called, you see here, with this name cos, okay? So this particular cos, it is becoming this particular function point. Okay? So cos acts as this function. The first argument requirement of tabulate is the pointer to a function, which in this case is cos function. Okay. And similarly, we can repeat this thing by using this sign also. This is suppressed here, but this can be done. And this is what will happen. Let us see what is there within the tabulate function. Okay, this is identical with this, and then we have a variable x. We have integers, number of intervals, and I. They are two integers. Number of variable is. This is, floor and ceiling are two of the functions. These are also available within math. Okay. So ceiling means the higher value. Last minus first, it is there. Double last and first. So this is the range. If initial and final, so it is final minus initial divided by the increment. So that will become divided by the increment. That will become the number of intervals. You understand that? Okay. And then we have a loop here, which runs from this 0 to the number of intervals. And I is less than equal to number of intervals. We are incrementing I. And now what is x? The first value plus I into increment. So if we start from 0 end to 90, and there are 90 values in between. So it value would be 0, 1, 2, 3, 4, etc. And then it is printing. These are the format. 10.5 means okay, total space allocated is 10, out of which 5 is allocated as decimal digits. Okay. There are three such, or there are two such placeholders. Those will be the values of x, and this is the value of that particular function. Okay. So this star f here would be this cos. Okay. So from here, this star f would be cos, and this would be cos of x, right? This is what we'll get from there. Okay, let us see. This is not a much difficult one.
Sir,
Huh?
sir, actually we have a class from 12.
Okay. So anyway, I will share it. Something more is there. You can run this program, okay, and you will see how we pass a function by using function pointer. Uh, so okay, when you have a class, you need to leave, but do you have any question on function pointer? Might be you have. You are has to be there. If you don't have any question, that is not a good sign. That means you are not studying or something. But whatever, you can write me an email afterwards, whatever. So the next part we'll be discussing is array pointer, a dynamic memory application, and the structures. Okay. Next week we have a test first, and then we'll proceed. Okay. Any question? So okay, then you join in the next class. Let us stop here today. Bye.
Thank you, sir.
Okay. Bye.